very bad. Work and stuff.
Don't do homework in someone else, don't do homework in this class for someone else's class, and vice versa, it's just, you should, when you're in there, you should be paying attention. If not, if you're still there, you're done with your homework, help someone else, it actually gets you better at your own school. Cause your Spanish class couldn't, I already hit record, I'll probably rant later. Chapter 9, what's chapter 9 on? Let's roll it in, guys, gals, and those that don't identify as either. Chapter 9 is on inferential statistics. With inferential statistics. Follow a process. Trying to. Infer. Or deduce. Something about the general population. Based on sample data. Making an assumption. About the population. So, back in March of 2022, in fact. On March 22nd or 21st. Of 2022. I collected the following data from online. About death rates for COVID. So, we'll talk about where, I'll make a little list, where, we'll talk about. Number of deaths. And total cases. Egypt was really high. Egypt had 24,277 deaths. Out of 495,373. And if we do the whole X over N idea for a proportion. The proportion for that is 0.0490. New Zealand, on the other hand, they had their shit together. They were fucking telling you, get the fuck, don't come in our country, don't you fucking dare try to show up. And if you're sick, we're fucking locking your ass down in your house. They fucking were serious about public health. They only had 2 years into the pandemic. They only had 163 deaths. Out of 497,731 cases. They had more cases than Egypt, but they locked down on that shit so goddamn quick. And we're taking care of shit fast that. Very few people died. This gives us a percentage or a proportion. If we divide 163 by 497, we get 0.0003. 3 zeros. That's really good. California. California, we had, at the time I did this, 87,485 deaths. Out of 8,465,358 cases. And if we do that as a proportion, it was 0.0103. This was slightly better than the United States as a whole. The US as a whole had 971,162. Out of 79,734,788. For a proportion of 0.0122. Doesn't seem like it's a lot better because we're one of only 50 states, but like 87,000 compared to like 971 is like 1 out of 12 or 13. But we are much more populated in those states. We got a coastal center, one of the longest coastline other than maybe Florida. Or Alaska. Alaska's got a long coastline. So we got a lot of coastal cities and farming communities living in town. We got one of the most populated states. Worldwide. Worldwide is the last one I wrote down. Worldwide was 6 million deaths at this point. 6,777,582 out of a whopping 500 million. 470 million cases, 737,068. And this gives us a proportion of 0.0129. Before I go on to the next page, just for comparison. The death rate. Globally. When we started. March of 2020. We were at 0.0471. Got a much higher death rate. Almost 5% died. Was dying. That's like 1 in 20 people. That's not fucking good. And then we got vaccines and people that took it. Started making it to the live list and. A lot of people that didn't take it. Many of them lived, but they got their loved ones sick and they died. It's kind of shitty. I know friends that like, we hate vaccines and they got like their loved ones dead. They don't recognize that they did, but. You visit mom and mom's fucking 75 and you're fucking carrying, you don't know that you're carrying COVID. What happened to my mom? We didn't take it to her, but did a caretaker and. She got COVID staying at home. Because her fucking caretaker didn't like vaccines. COVID didn't kill her, but she went downhill from there. But yeah, it happened. Alright, so. What's the actual death rate for COVID-19? After vaccines were introduced. Death rate. After vaccines. And this was when the vaccines were in. Well, all of these were different. no matter which country we looked at, which region we looked at, they're all different. But there's gotta be some range of numbers. All countries were different. But there has to be a range of numbers. That holds the true value. I could say from like 0.0001. Like if I were on a number line. All the way over to 0.1. And then I got every country. I could say it's in this range. And feel pretty confident about it. If I wanted to go from maybe 0.00. How many zeros do I want to go here? Oh, fuck it. We'll stop there. So there up to maybe 0.018. Well, this is a narrower range. So I am less confident. About this. And since this was an ongoing changing thing, like this was just a picture in time. It's still changing, people still die from COVID-19, not very often nowadays, but it still happens. It's hard to know what the actual value is, but there's gotta be some range there. And so with stats. We will generate, not just randomly pick, but we will generate a number range. For a. Specific. Confidence percentage. This range is called the confidence interval. So this is how they do it. Well, this is how they confirm it. We're gonna go over how we do it in a second. But what they'll do is for a random thing, like for some other event. Let's say for an experiment. They collect sample data. And using. Mu of x and standard deviation of x. Come up with a range or interval of numbers. And we can choose to set it. If we want super confident. Like say 99% confident, you're never 100% confident. Like, so let's say we want 99% confident. We make the interval or range really wide. Wide, like wide load wide. Like you're taking up 2 lanes, motherfucker, get off the road wide. Like Hefe sitting on a bus seat, you're in the fucking way, Hefe. We're talking seat. So we can be confident it has it. But now we got a really wide range number, so we don't really know what it is. Like I can be 100% confident. If I say the proportion is between 0 and 1. That doesn't help me narrow it down, right? Proportions only go from 0 to 1. So I can be 100% confident that I have the value, the true value is in the range. If I just make it as big as possible. But like the narrower we make the window, like this is a narrower window. That's pretty good. The smaller you get the window, the more accurate your answer is. But the confidence goes down. The narrower an interval, the less confident. And the way we do it is we relate our confidence interval, as you'll see after we do some more stuff with it, to the area under the bell curve. What's your guys' favorite app? Not you, Val. Your answer is gonna be way different than everybody else's in this room. I'm guessing the majority of people in here are gonna go with TikTok. Or. Instagram. Who likes TikTok? Who likes Instagram? Anyone still use Snapchat? It looks like Instagram. Anyone like, is there another one that I'm not listing? X? Is anyone on Twitter? That's okay, I use Facebook too. Let's go with Instagram. Let's look up Instagram data. I want to use an example from real life here. So if everyone's, Kelly, are you done writing? All right, Kelly's done, everyone else is done. So let's come up here and look up percentage. College age Instagram users. %76% age 18 to 29. What are they fucking calling college age? There we go. Let's use this one. 31% for age 18 to 24. Okay, I'm gonna go back to the paper real quick. But I wanted to pull some fucking data from real life. So college age students 18 to 24. On Instagram. What was it 31%? 31% globally. I am deliberately gonna pick a percentage for a sample that doesn't have. Isn't 31%. So let's say. We had. Let's start with 70 out of 200 students. In our study. Use Instagram. If we turn this into a percentage, we do 70 over 200. And we get 0.35 or 35%. Now what we're gonna do is we're gonna go over to StatCrunch, and in StatCrunch. I'm gonna call it something that says applets. Confidence interval. And I'll show you how this kind of works. I'm hoping 70 is a good number. I might want to change that to 68 or something like that in a second, but I'm estimating, I think that'll be a good number for what I'm going for. Alright. While you guys are doing that, I'm gonna get StatCrunch loaded up. The applets is just to show you the idea of what's going on, a lot easier than me trying to draw it by fucking hand. And you'll see why in a second. You guys ready? So I'm gonna go open StatCrunch. And go to applets, confidence interval, and we're doing a proportion. So I'm gonna select for a proportion. I am going to use my sample of 35%. And my initial sample size was 200. Confidence interval of 95%. Cute. Oh, this is a little hard because it doesn't show the 0.31 very well. Wow, this one didn't work that well. So what they do is that each line here is a. Like what if we sampled a different 200 students or different 200 people? How many of them would actually include 0.35 in the number range? This black line here is 0.35. And they found like the mean standard deviation, which we'll go over in a second how to do by hand. And they go, like, if we did this randomly, what other groups would we have? Like this top one, this top group here is row 1. It had a sample proportion of 0.29. And its range was 0.227 to 0.353. It included it. This might be easier to do 0.31. Let's go with I'm gonna change this value here. Let's go options, edit, and we're gonna change it to 31. That's what we looked at. So they go based on the number 31 and they start doing the mean and standard deviation for there. And they start generating a lower limit, which is a smaller range number. Like when I was doing it by hand, I had the 0.00001 and then the 0.1. The 0.00001 is like the lower limit, we'll show it on a picture. And the upper limit is the larger number. And so they go through and they simulate a bunch of examples here. And all of the green ones have 0.31. Which is our black line right here. The ones that are red did not. If I click on this red one right here, let's see what line is that. They're red over here. That's red. This simulation had 0.185 to 0.305, which means 0.31 is outside. Does that make sense? So the way confidence interval works, it doesn't give us the percentage chance that our number, our range has the actual number. What it does is it gives us the percentage chance, not really the percentage chance. If we do it 100 different groups, how many of them would actually contain this number? In general, this one has actually 98 containing the value. Generally, it's around 95. This one's actually a lot different than normal. If I do 1,000 intervals with it, I'm getting closer to the suspected confidence interval level. I do 1,000 more. And I could keep tagging it up and I get generally closer and closer to 0.95. Where most of them include the number, but some don't. How that's gonna work, this is like some tricky shit on paper. It's kind of a little bit easier to show on paper, so I'm gonna go like breaking it down to one idea here. And, do it for the video as well. So what they do, I'm gonna base it on my 35% right here. And I'm actually gonna show you how to calculate whether we have it or not. So recall for proportions, we did this in chapter 8. Mu of p was n times p. No, it was just p. Mu of p was just p. And standard deviation was the square root of n times p times 1 minus p. In our problem here, we had 0.35. This one, I don't know offhand, so I'm gonna have to calculate it. It's the square root of 0.35 times 0.65. That's not n. N times p is gonna be 70 times 0.65. That's off. That's not the right formula. I'm like, that's too high. It's not times n, it's divided by n. So it's the square root of 0.35 times 1 minus 0.35 divided by 200. Just gonna calculate it real quick. And I'm getting for my standard deviation 0.033. 3.4 if I round appropriately. So we're gonna make a bell curve off of that. We're gonna go out 2 deviations either way. If I go this way, the next one is 0.384. I'm just adding our standard deviation. And if I do it again, 0.418. If I go the other way and subtract. It is 0.316. And. Zero point two eight two. So if I wanted a 95% confidence. I would do between plus or minus 2 deviations. Because that's 95% of the area, plus or minus 2 deviations. With my data, what I would say is. I am 95% confident. That the true proportion. Why did my screen screen? There we go. True proportion. Of college age students on Snapchat. Not Snapchat, just Instagram. Is between, and I list those two numbers, 0.282 and 0.418. This is using the empirical rule for 95%. I'll actually show you what happens when we do the actual thing in StatCrunch. Actually, I'll make a list of them right now. Yeah. Okay. So what this 95% confidence means. If I recreated this experiment 100 times. I can expect. Approximately. 95 of them. To contain. My p hat. Of 0.35. And if 95 of the samples out of 100 are have that in there, it's probably. It's probably close to the true proportion. In this case, we happen to know the true proportion because. They know how many people are on Instagram and they can see how many people are at college age. Or college students at any time just by collecting public data. In this case, we know it's 31%. And notice. That our range. Or interval. From 0.282 to 0.418. Contains 0.31. Where I would do a number line, 0.31 is actually closer to the bottom side. But it's in the range. So what's going on here, if I do this number line. This is, I'm just pulling the number line from the bottom of. My bell graph I had on the other page. The bigger percentage of area we include, the wider this range gets. Like if I said 99%, I could go out to 3 deviations. If I only wanted like 90%, I gotta go narrower. But they say, they call this. This distance or difference here. It's called the E, which is the margin of error. It's how far off we can be. And so the width of our interval. Well, I can go E this direction and I can go E this direction. And if I add those up, I get 2. So that's like P. This is like P plus E. And this is P minus E. Well, P hat. I can actually find it by taking. One of the numbers and subtracting the middle. And if I do the absolute value, gonna get the same answer either way. If I take this number and subtract the middle, or if I take the last number and subtract the middle. If I do the absolute value either way. My E here. For our problem line here was 0.068. This is so much easier than what I'm doing by hand. Trying to illustrate what's going on with the bell curve. Cause you're just gonna throw it at stack crunch, it's gonna be easy as fuck. But if you don't understand how it relates to the bell curve, which is what we've been saying, we want everything related to normal bell curve. Like if you don't like see any connection to it, this is all fucking meaningless. This is all just computer jargon. What we're gonna do in Stack Crunch, we'll take a break first, but in Stack Crunch. We're gonna do stats. Proportion stats. And at this point, we're given it some options, it will say. One sample or two samples. Two samples we'll do in a later chapter. It will ask us if we want. Or do we have data or summary? So that's like a sub thing on each of those. And they also have an option called, it says power sample size. And this last one is useful to pick a sample size. Based on the confidence level that you want. And with that, I'm gonna hit pause on the recording. Let's take a 10-minute break. We're gonna go back to Stack Crunch. And we're gonna take a look at those stats, proportion stats. We only had one sample in our fictitious sample of 70 out of 200 people. So I'm gonna say one sample. I do not have a column that lists 200 responses. Where 70 of them were yes. So I'm just gonna say with summary. I'm gonna tell it 70 people out of 200 said they use Instagram. I keep wanting to say Instacart, that is not the same thing.
It is my favorite.
And I'm gonna tell it I want a hypothesis test of 95. And not hypothesis, confidence interval, sorry. We do hypothesis test next chapter. Just confidence interval now. Thankfully, it's on the same fucking thing, you don't need to learn a bunch of charts. They're on the same thing because they're directly related, and I'll show you how they're connected later on. And we'll click compute.
Is that always gonna be your method?
Well. For proportion stats,
For proportion?
for proportions, when it's means, which we'll do on Thursday. We'll show that it's a different one, but it's under T stats.
Oh, okay.
But it'll notice it has a one sample and a two sample, just like proportion has a one sample and two sample.
Okay,
They have, it's set up very similarly. This is our lower limit. Notice when I calculated it by hand, I had 0.282. Which is pretty close to this, it's not exact. And I had 0.42 over here. So I'm gonna write down what Stack Crunch reveals with this when we did it in Stack Crunch. You can't see what I'm writing, but you saw me put it on the screen, we use success equals 70. That. Okay. I'll do it again where the two screens are up at the same time. We had 70 here. We had 200 here. And we have a confidence interval here. So I had success equals 70, observations was 200. This is like your X and your N that we've been doing with frequent relative frequency and or frequency and shit like that. Relative frequency. The error. This is showing us effectively. Like what one deviation is. Now we're gonna go look at this on the normal calculator as well. I wanna see you see how this ties into the normal calculator as well. Confidence interval plot. Let me edit this one to have the plot in there. So if you click on confidence interval plot, it makes a little number line and it shows you the range. Notice the true proportion with 31% is in this range. What if we had changed this up? What if I had only asked 100 people? Or let's say I asked 400 people. I'm just gonna double all these numbers. Let's say I did 140 and 400. This is still 35%. I'm still gonna go with 95% confidence interval. And let's look what it does to our number ranges here. I get rid of that writing there. Oops. Notice. A little bit more over each other. This was 0.283 and this is now 0.303. This was 0.416, this is 0.396. The numbers have gotten closer in together. The bigger n gets, the closer in the numbers get. This still actually contains the 0.31. So let's say I look at this again, let's say I had 140 over 400 and I wanted to be 99% confident. Or 90% confident. If I do 90% confidence, 0.31 is actually lower than this number. Not by a whole lot, but the true proportion is not inside this region. So our lower limit and upper limit wouldn't give us the actual value. There's a lot of mathematicians hate stats because you never know if you're right or you're wrong. We happen to know we're right because there's actual data collected on it. But in general, you do not have the data collected for an entire population. I don't even know if the 31% is accurate. I'm assuming that the thing online that said 31% was collected from information from Instagram. And looking up like how many of them are college age students and looking at college age students numbers globally. I don't know, they could have done something very much like this stuff. You never know what the true proportion is, but you're trying to get a number range that is likely to have it. Okay? I could, if I had too large of a number range. Let's say I went up to 210 and 600, this is still 35%. And now my lower limit does not have the true proportion. 0.31 is below that. So depending on what you pick for n and what your proportion is, may or may not capture it. The bigger your n, the narrower your range gets. Let's go back to looking at it, talking about this stuff on paper. So yeah, are you confused? If you're not, you're fucking lying. This is a confusing topic. Because people are inclined. Share screen. We are very much inclined, let's see, where is this, let's think about that one. We want to say. As people. Humans. Instinctively, we wanna say that 95% confidence. Means. There's a 95% chance. That our interval has the true value. And it looks this way, but this is not true. We will never know what the true value is, but if it's inside the interval. It's either 100% if it's inside. The true value is inside it. Or 0% if outside. What is true. For the interpretation of confidence interval or confidence percentage. The percentage tells us. How many we can expect to have it. How many samples would have it if we did this 100 times? Are likely to have it. To hold our value. Which is not necessarily the true value, but hold our value. Out of 100 samples. So we've been saying for the empirical rule. 95% is plus or minus 2 deviations. Let's go see what it actually is. It's close. You're good? I'm gonna go into the normal calculator. And we're gonna do between. I'm gonna put in 0.95. The normal calculator does the bell curve. These are actually, and the normal calculator does a z-score, which does deviations. 95% is actually plus or minus 1.96. So it's close. The two deviations is an easy one to remember. You're just doubling it, you're not having to get out a calculator, do 1.96 times your value. If we look at 90%, some common confidence interval values. So I'll type them over here. 0.90 is a common one. I didn't say 0.90. That one is 0.90, the top one. Those are three common ones. We just showed that this is 1.96 deviations. If I want 90%, I change that to a 0.90. I click compute. And it tells us about 1.645. Like if I rounded that to 3 decimal places, I'd get 1.645 on both sides. And if I wanted 99%. We would have 0.2576. Or 2.576. Here. Those are the three most common confidence intervals that are asked for. Every once in a while, StatCrunch or the homework will ask for a different percentage. I want to show how this relates to what we were just doing. So we calculated for our 70 and our 200. I had a mean of 0.35. And when I did that calculator thing, I had said. I gotta go back to that page. I had rounded to 0.034. I had rounded to 0.034. I'm gonna actually do that calculation, put the whole value in here and show you how it relates to what we're doing. Because I want you to see the overlap between standard. The standard calculator, the normal calculator and this confidence interval thing. If I do 0.35, I'm recalculating this thing real quick. If I do the whole thing that my calculator had for accuracy. If I wanted 95%. It's giving me 0.2839 and 0.4161. And if I go over and do the confidence interval thing. Of 0.95. What is that for 4 decimal places? Which is that value right there, right? And that one rounded is that value right there. So what this confidence interval calculator is doing is it's going and it's calculating the mean and standard deviation for you. And then figuring out all this shit for you to tell you. Basically, the percentage of samples that will have that value in. So it's directly connected to the normal calculator that we've been doing and the bell curve we've been aiming for. It just doesn't follow the empirical rule because that's done for human to do by hand quickly. We have 2 deviations and the actual is 1.96. When I did it by hand over here. When I did this by hand, I had 0.282 for my low one. And I had 0.412, 418 for my high one. And notice those are off by just a little bit. They're off to the thousandths place. That should be a 2 on mine, and that comes from the empirical rule being not exact. It's just, it's close though. And I was able to do it by hand rather than having to get out a computer program to do it. That's the point of the empirical rule. So the idea of doing this confidence interval is. I don't know what the true proportion is. But I'm 95% confident that it's gonna be in that number range. It's gonna be between basically 28.4% if I did this as a decimal or a percentage, and 41.6%. And it turns out that it actually was. It says 31%. That's because I thought 35% might be close enough if I picked the numbers right. But in general, you don't know what the true percentage is. Okay, you're never gonna know if you're correct or not.
Should we be doing this to check our work once we're done doing the first one?
You don't need to. But if you do it to try to build a sense of understanding of what's going on, it doesn't hurt. Doing this though required doing those calculations. Okay. So, let's look at some homework problems. Let's start that or make a fresh one. So it says determine the point estimate. This is number one. I'm gonna do like 1, 4, and 6 right now. Just to walk you through kind of what's going on. This will help. Your numbers will vary. Okay. So my question number one on homework, and I'll switch back over to the monitor in a second. It says my lower bound, which is the same word as lower limit. They mean the same thing. Is 0.304. My upper bound is 0.566. Motherfucker, what are you talking about? I just turned the problem on. It didn't fucking wait at all, did it? It says n equals 1,000. And they want us to find the point estimate. They want us to find the margin of error. The number of individuals with the trait. It says characteristic, but traits means the same thing and it's shorter to write. And now I'm gonna come over to StatCrunch or the projector and show you how to do this. I need to change the recording too. This one is more one you kind of have to do by hand. I think 1 and 2 were kind of like this. So this is giving us a bell curve range. That's a shitty bell curve. I don't know what confidence interval it is. Did it even say? No, didn't. It's got 0.566 here. The point estimate is the p hat. The p hat is the one that's right in the middle. The way you can find p hat by hand. If you just have the lower limits and upper limits. You can take the lower bound and add the upper bound and divide by 2. I'm gonna take 0.304 plus 0.566. And divide by 2. Just everything wants to turn off. Computer wanted to turn off. And if I do that, I am getting 0.435. That answers part A, the point estimate. A. Margin of error will be B and the individual with trait will be C. The easiest way to find your margin of error given these numbers. Is take your point estimate, what you just had, and subtract the lower bound. 0.435 minus 0.304. I get E is 0.131. You would have gotten the same thing if you did 0.566 minus 0.435. You gotta take one of them and subtract the middle value and make sure your answer is positive. So they both equal to 0.131. We actually, you did this individuals with trait thing a bunch on the fucking midterm. There we go, if the proportion is this and you had 500 people or that, you usually did increments of 100 or 1,000. How many people would you expect? You're basically, you take n and multiply by p hat. 1,000 times 0.435. I should get 435 people. Approximately. Yeah, that's what they should have got if they came up with these numbers. There's no question about that. But if I were to reproduce this thing, it'd probably get closer. So funny, Krista. I'm looking around at everybody. I'm gonna go enter those values into StatCrunch. And we'll move on to the next problem. Does anyone need this up longer? 9.1 takes longer to do than 9.2 and 9.3 together. Because you're like, I'm having to try to explain the idea of combinance intervals here, and it's not a thing that's easy to grasp for people. It's a pain in the ass. To the nearest thousandth, I had 0.435. And my margin of error, I calculated this at 0.131. And here I had 435. And let's go down and take a look at. Let's go with. Number 4 looks good here. So I'm gonna write down some information about this on the page before I go back to it. It says 2,290 adults. Did a poll. And 399 had donated blood in the past 2 years. I'm actually gonna do this on screen, I don't need to switch back. So P hat. Where's my marker? This is X divided by N. So it should be 399 over 2290. I can find this on StatCrunch real quick. I'm going to go to, I don't know which confidence interval they're gonna ask me. But I know this is a confidence interval question. So I'm gonna go stats, proportion stats. One sample and with summary. I'm gonna enter in the 399. The 2290. And I might have to change this confidence interval value later. But if I click compute. It tells me the sample proportion. Right here. That's p hat. If you want, you can verify this in your calculator. By dividing 399 by 2290. So they want 3 decimal places, that would be these 3 numbers. It looks like I don't have to round up, I'm just gonna enter 0.174. Okay. You can do it in a calculator, you're just finding proportion, you've done proportion a lot, you did it on the midterm already, you know how to do it. You're still using the shit we did pre-midterm. But StatCrunch will do it for you if you wanna do it, speed it up. There's a good chance they're gonna ask 95%. So I did 95%. I'm gonna click check answer. Ah, shit. Alright, let me get rid of the marker shit here. Why can't I move this bar? There we go. Verify the requirements for constructing a confidence interval about P or so. Shit, I didn't go over this. It's related to, I'm glad I did this problem. Remember when we did, 8.1 or 8.2, it was on proportions. We said N times P times 1 minus P had to be greater than or equal to 10. And we said little n had to be less than 0.05 of big N. These are the requirements to do confidence. They were the requirements for it to be a normal distribution. And since this confidence interval is off normal distributions, it's the same requirements for this. So I'll put that in what I scan. But it's, I'm not writing anything down different than what I have written on the screen. So let's figure out what that is. They had 2,290 for big N. We had 0.174 for P. Think. Yeah. And then we want 1 minus 0.74, and we want to multiply that all out. That you're gonna want to do in your calculator. I'm getting. I don't know what they're gonna ask me to type in, I'm getting 329. That is a 9. And 0.12796. That is bigger than 10, right? I'd rather have $329 than $10. It says a large country. I have to assume a large country, 2,290 people is definitely smaller than 5% of a large country. Like 2,290 people is like less than 5% of Tulare. You know? Well, maybe Tulare can, definitely by size. I saw you had more than 50,000 people. So we're gonna come in here and try to answer these questions here. We can say, let's see. Did they say it was random? It looks like this first part says the sample blank. I'm filling in something about a simple random sample. I think we can reasonably assume it was random since it was a reputable polling organization. We have to assume they did random sampling. The value of. We just calculated this, n times p times 1 minus p. And they want 3 decimal places. I'm going off of that right there. I'm gonna use 329.128. That's what I calculated for n times p times 1 minus p. That is greater than 10. And the sample size. We can assume it to be less than 5% of the population. Not population proportion, population size. The sample size can be assumed to be less than 5% of the sample population size. Because it's a large country and we only ask a little over 2,000 people. With those 2 criteria met, we can say. We can assume. Oh, those are the 2 requirements, so we met them. So we're gonna say check answer. It's not a fun problem, you're gonna need a calculator on this. They tricked me, they want 90%. So I'm gonna come back over to StatCrunch. And you can re-enter it, or you can just do edit. And change this to 90%. And the way we say it is we are 90, whatever percent it was, so 90. We are 90% confident. The proportion of adults in the country. Aged 18 and older, blah, 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 is between. How many decimal places did they want? 3 again. I'm gonna use the 3 decimal places from the lower limit. 0.161 is my lower limit. That's the first number. And my other number is the upper limit. 0.187 to 3 decimal places. That's what they want us to do. And you don't want to say there's a probability, you're gonna say confident every time. If they give you a choice, you want confident, not probability. And the other one I want to show you is the 6th one down, that one. So a researcher wishes to estimate the proportion of adults who have high-speed internet access. What size sample should be obtained? When they ask you what size sample should be obtained, we're looking for that power sample size. On StatCrunch. That does not look good, sample size. So I'm gonna come over here. And I'm gonna blow it up real quick so you can see the whole thing real quick. Stats, proportion stats. One sample. Power sample size. Okay, let me shrink it back down so we have our text here. So if they give you a previous estimate. This is our P. If they don't have a previous estimate, use 0.5. The fuck? You actually want to click on confidence interval width up here. Okay? This has a whole bunch of extra shit that we'll never do. This part's complicated. Confidence interval width is not so bad. It tells us our target confidence percentage is 90%, so we're gonna put in 90%. The previous estimate is the percentage. So I'm gonna put this in as 0.48 for part A. And while it doesn't make this necessarily clear, when they say within 0.01, that's my E, my margin of error. W is 2 times that. And if I double 0.01, I get 0.02. So I'm gonna put that in for my width over here. No matter how big I make it, it wants to put the compute fucking thing off screen. If you can click compute, it gives you the sample size. That's what we want to enter. 6,754. And then it says part B doesn't use any prior estimates. You want to first off reset the width. Because notice it's not 0.02 anymore, it's really close, but it's not 0.02. Reset the width, and if there's no previous estimate, change that to 0.5. And that gives us 6764. And we just did 3 of the 18 problems. There's problems from 9.2 and 9.3 in here. So you won't even be able to do the other parts of these. This is like the chapter 9 review. We did probably half of the 9.1 questions right here. Walk through them. So you can see how everything works. Okay? You are free to GTFO or stick around and ask questions. We're gonna do 9.2 and 9.3 on Thursday.